Come back. Now let's take the another problem. The transfer function of a process, a measuring element and control valve is respectively given by, these are the value, a proportional controller with gain of Kc is equals to 2 is used. What is the steady state error? What is the steady state error in the output for a step input, unit step input in the set point? Round off to 2 decimal places. So we need to find out error. So error is this, right? So error is what? Input minus output. So error is R, which is R infinity minus, here it is C infinity. Okay, so we need to find out the error, and R input is given, and the magnitude of this input is step input, it is 1 by S, and the magnitude of step input is here it is, if the magnitude is not given, so what, if magnitude of step input or any input is not given, then what we consider will be 1, or if it is given, then no problem. Okay, so now we need, for this whole process, we need to find out C by R. So C by R is equals to, in the numerator, right, in the numerator, multiplication of all the transfer functions, so Kc, Gb, Gp upon, in the denominator 1 plus, right, all the in the numerator all the transfer function in the open loop, right, and in the denominator all the multiplication of all the transfer function in the control system. So Kc, Gb, Gp and Gm. Now we have the value of all the transfer function and the value of, we know we know the value of gain also, which is 2. So now just substitute all the values. So C by R is equals to, the value of it is 2, then Gb is 3, 2s plus 1, this is 5 upon 3s plus 1 divided by 1 plus 2, 3, 2s plus 1, 5 upon 3s plus 1 multiplied by 1 upon 4s plus 1. Now just simplify this and you will get C by R is equals to, 30 4s plus 1 upon 2s plus 1, 3s plus 1 and 4s plus 1 plus 30, right? And we know the value of input is 1 by S, so substitute R is equals to 1 by S here. So C is equals to 30 4s plus 1 upon 2s plus 1, 3s plus 1, 4s plus 1 plus 30 into 1 by S. Now we need to find out the output, right? So here we apply the final value theorem, FBT. So what it says, C infinity is the limit of S tends to 0, S of Cs. So just substitute the value here. So I'm just going to rub this. So C infinity comes, S is cancel out, S of 30 4s plus 1 upon 3s plus 1, 4s plus 1 plus 30 into 1 by S. Here the limit goes, S tends to 0. This S is cancelled, and then we substitute the limit S is equals to 0. Then S C infinity come 30 upon 30 and then 30 plus 1. When you solve this, you will get the value of this is 6. You need to just multiply this, open the bracket of this. So this is what? 6s square plus 5s plus 1 again it is 4s plus 1, then again 24s cube, then 20s square plus 4s plus 6s square plus 5s plus 1. So when you resolve this further to 26s square plus 9s plus 1. So here this is C infinity comes what? Just write down one more step here. So it is 34s plus 1, and this is 24s cube plus 26s square plus 9s plus 1 plus 30. And now we need to substitute the limit. So this has become s, the limit is s0, so this is in the numerator. This is 30 into 1 is 30. This is 0, this is 0, this is 0, and 1 plus 30, so this is 31. So C infinity, the value of C infinity is 31, and now we need to find out the error, which is epsilon. So error is what? R infinity. Error is what? R infinity minus C infinity. So R is how much? The magnitude of step input is 1 minus 30 upon C infinity is 30 upon 31. So 31 minus 30 divided by 31. This is 1 upon 31. And the value of this is 0.032. And we need to round off up to 2 decimals. So 0.03. And this is the final answer. Thank you.